Hey everybody, this is Brad Dyke reaching out to you, and today we are going to cover one more part of the build my new data center concept, and that is the nature of, okay, if you're a diehard, you don't go out and you don't buy your own pre-made cables for your data center. Instead, you would do your own cabling itself by taking a Cat6, Cat7, Cat5e cabling and basically running it the lengths you want it to be inside your racks to your patch panels and so on and so on, and then from that point stage be able to connect the switch to the patch panel through your Keystone jacks, which by the way, this is what a Keystone jack is, and the RJ45 connector goes into it like that, and this is going from your switches to this point, and then your servers go into the port. And so it's this end we're talking about today. It's called an RJ45 head. As you can see, it's like a bigger version of a telephone jack. It really is. It's pretty big. So what we're going to be doing is we're going to take a good old-fashioned cable and we're going to make basically a RJ45 mounting, and I'm going to show you how to do that on one end, and then I'll finish the other one secondly, and to show you how overall that would become. So with that being, let me go ahead and flip the camera. And so basically in a nutshell, what we have here is we have a sample cable. One end is already cut, the other one is not yet, but it's ready. And we have to have two primary tools initially. One, a pair of steel scissors like this. Steel scissors are better than the plastic ones because they've got some veridity and better control when you're cutting them, because you're going to be doing something, and I'll show you what it is, that's important, that allows you to be able to cut carefully. That's a key detail right there. Cut carefully. So what I mean by cut carefully is we take our scissors like this, and then we're going to ridge line the outer shielding of the wiring so that we can cut the shielding but not cut the wires inside. That's why using the steel scissors is a little bit better in regards to handling the actual more plasticky base that tends to break out pretty easily. So at this point stage, you can see you have your wiring here. There you go, and then they're twisted. And the reason why they're twisted is because that allows them to basically keep the insulational format or function of the wiring to the point so you don't have a lot of leakage. That's something we can cover in a future reference. But right now, as you can see, these are twisted as they are, as you can see. And the key detail here is we're going to untwist them in a certain order, okay? Now, if you're not sure about what you want to do untwisting wise, take an existing cable like this and look at it, and then it will tell you what you want to do. And you can do that to copycat if you want. Same way with other pairs of wirings. You can look at them, and this is a Class A version, where this one is a Class B. I prefer Class B personally. And so basically what we do is we unravel the wires like such. And the untwisted pair will be side by side. And then of course you'll be untwisting, in this case, I'm going to make this pair to pair, so it's going to be blue, white, green, green, white, blue. So what I'm doing here is, if you will see what I'm doing, is I pass that through as such, and then now I've got the order of my wiring in the way I would particularly myself like to have it, and at the end my brown, white, and then brown. So there are my wires. Now this is where it gets a little tricky, but it works if you do it right. You place your thumb in the center like this, and you bring your wires in the proper order that you have them spread out until they can come together in a straight row, like that. Now the thumbnail is all you need. Take your thumbnail and put it between the base of the installation and the top of the cut, and that's going to be what you need so that it will fit snugly, correctly, as you slide this unit on. Now orange is to the left in this case, so I'm going to slide this down. At the top of the unit is at the bottom. As I'm doing it, I got the bottom of the Cat5, or in this case Cat6 head, facing upwards, so it's going to slide down on this. But once again, I'm going to kind of straighten out my row as much as I can, because the straighter it is, the better it will slide on. And again, I'm using my thumb length to the base of the shielding for the distance I need to cut correctly to reach my goal. Now, it's also advisable to have a trash can for you to shoot your wires into, but when you're done, you're going to have this little edge of wiring. Then at that point stage, you're going to take the bottom, like I showed you, and you're going to feed it in, and it will sleeve right in, and you bring it in tight and hard. Look at how the insulation shielding is inside the RJ45 head. Now, at that point stage, I introduce my crimping tool. This is the best crimping tool in the world. It's a center lateral crimping tool opposed to a right lateral. People have their choices. This is my choice. And I press that cable in really hard, and then I go ahead and give it 2 crunches, and voila, we have ourselves a cable that is good to go. Now I'm going to pause the video for a second, and I'm going to get this other side done really fast, and then I'll show you the testing process. One side note as I'm doing this is if you look here in the middle of the spread, you might have what's called a plastic isolator or string. You're not going to be able to pull the string out, but you can cut it down, or you can cut the plastic separator down inside, because those can't impede your ability to bring those cables together. But I just wanted to make note of that as I'm doing this. I forgot to mention that depending on what kind of CAT cable you buy, may have different types of what we call pull-throughs that keep the wiring in its place. But I'm almost done. Okay, so we've got the units made. Here's the sample cable, and it looked like one of the wires flipped. But let me show you what it means in an error-wise when that occurs. And by the way, don't worry if your head gets crossed. The first 2 or 3 times you make your cable connections, you will have your fingers and your hands and your cutting and everything will show you that it's sometimes just a matter of habit. Once you get into the groove of doing it, you're making cables well every time. But as you can see here, 2 wires got flipped on one side. I'd have to cut that head off on that side, correct the orange-white to make that correction. But what it should look like is this. So after the correction, you can see here on the black side that it is now properly wired. And I wanted to show you what it would look like if it was an error, and what would it look like if it wasn't. Now, one last thing to show you is the factors and differences between what we call the standard CAT5, CAT6, CAT7 heads and CAT cabling that is open or plenum versus what is known as shielded. Now, shielded means that you're not going to be able to put what's called a style sensor around the cable and capture data. It's a secure kind of cabling. And if you look at it, it has metal wrapped around it, not plastic. And this head, this plastic, is around a metal aluminum coating that's inside underneath this that acts as the shield. And this gives you both even better impedance on the cabling, but also it gives you a secure cable. Not that people need this, really this is more for classified environments and or highly restricted access control ports and things like that. You don't want anybody connecting to this cable. This is the kind of cable you want to make. But the process of building this cable, even though it is a pain to do because this particular mounting is different, it's just exactly the same thing. Use the same tools, the same testers, scissors and everything. It's just a different class cable. So I'm hoping that this helps you guys understand, especially you diehards out there who just want to make their own cables from point to point, how easy it really is to build your own cables. It's perfectly okay to go out and buy pre-configured, bought off the shelf. You did the measurements and you bought bulk cabling, and you know that because this stuff is all melted into its frame, or molded as they call it, molded heads, to give a little bit more stability to the cable, and that's a great feature. But you have both sides of the fence, and in some cases, like I do both. Sometimes I have a special need, so I will make a special cable for that. But all my standards, I'll use a pre-bought cable because my time's precious, and so is yours. Well, I hope this helps you. Remember, this is called a Fluke network analyzer. It's not the only one out there. You can use what's called an LED analyzer. It's just a simple $15–$20 Cat5 tester that can test 6, 7, 5, it doesn't matter. But it doesn't do length testing. It doesn't do impedance and ohms resistance and things like that such a device like this can do. But you buy what you need, and that way, you're being cost effective, because we all live on a small budget and we don't have a lot of money, but thanks to eBay and many other different sources, we can play and experiment. So keep doing that. Have a blast. God bless, and have a great week.